Hi my viewers, welcome once more to my channel. Today I want us to look at differentiation from the first principle. So I'm told to find dy over dx from the first principle if I'm given y as x squared. So let us look at the solution. So if y is equals to x squared, then I'll start so that where I have y, I will add change in y. So I'll have y plus the change in y is equals to, where I have x, I will include the change in x. So I'll have x plus change in x. But now remember my x was squared, so I'll need to square everything in brackets like that. And then if I'm having x plus change in x squared, it is the same as having x plus the change in x times x plus the change in x. So let us expand this one first. I'll have x times x, which is x squared. X times change in x will be equals to plus x change in x. You have to note that x times change in x is not change in x squared, but it is x times change in x. Then plus change in x times x is x change in x plus change in x times change in x is change in x squared. Then if from there we can collect the like terms, I will have x squared plus this one is 2x change in x plus change in x squared. So this is what we have after expanding this value here. Let us replace them. We'll have y plus change in y is equals to x squared plus 2x change in x plus change in x squared. Then from there, we can take y, we can take this y to the other side, so that I will have on this side I remain with change in y. So change in y is equals to x squared plus 2x change in x plus change in x squared, then minus y. Then from there, we know that, but our y was equals to x squared. So I'll come to this expression and replace my y with x squared, so that change in y is equals to x squared minus 2x change in x plus change in x squared minus this y, which is the same as x squared. I have that. Then from there, you find that I have, this was plus, I have positive x squared and minus x squared, which will cancel out, and I remain with change in y is equals to. So you find that for these two values, change in x is common. I will have change in x, which is common. I factor it outside the brackets, and here remain with 2x plus change in x. That's what we have. Then from there, I can divide all through by change in x, all through by change in x, so that this one will cancel out. So my change in y over change in x is equals to 2x plus change in x. But we have the limits. We have the limits when change in x is equals to 0. So that if this change in x is equals to 0, where I have change in x here, I replace with 0. So therefore my change in y over change in x is equals to 2x plus a 0. Then my change in y over change in x is equals to 2x. This becomes our answer after differentiating x squared from the first principle. That's how we solve it.